Hey guys, welcome to 3.5, and this is the lesson that gets a little bit confusing. Up until now we graphed into 2 dimensions, and we're moving into graphing linear equations in 3 variables. And this is a short lesson, we're not going to push on it too much, but we want to make sure we get it right. Instead of having our regular x and y little axis, now we have a 3-dimensional axis. And the best thing I can do to show you this, I showed you this in class also, is when you look at a book, right? You have a length, you have a width, and you have a height. So there's 3D. Now the axes are now named a little bit different, right? Your x is your red one, and it's kind of like the one that comes back and forth. Your y is your horizontal line, and your z is your vertical one. The only thing that changes is for you to understand that on this side where your y is negative and your z is negative, that's where your x is positive. And on the x-axis, whenever z is positive and y is positive, your x is negative. That's the only thing you want to remember is how they go, okay? We get this down. This is a very easy lesson. Let's try and graph those 3 points and see how this works. Remember, they are in order, x, y, and z. So I'm going to go, well, where is x? I have a blue in my hand, so where is x negative 5? 1, 2, 3, 4, 5. I have it right here, right? This is where I am. Now, where is y 3? 1, 2, 3. So on my 5, I need to come to where I meet my 3, right? And then I'm looking at my z, and my z has to be 4. Where is my z 4? 1, 2, 3, 4. It is right here. So somehow they all 3 meet in one point. And you're kind of going to have to make them meet in one point, right? It's just the way it goes. Well, actually, that's not correct. Right? See, I confused myself. They kind of meet here. And from here, my z is 4. I bring this up. This is the actual point of intersection. So the way we do it is we connect x with y. We see where they met. Then we kind of bring up to where it meets z. And that's our connection point. Let's try another one. X is 3. Where would x be 3? 1, 2, 3. My y is negative 4. 1, 2, 3, 4. Right? This is about where we are. So if I would have to bring this like this, they kind of meet right here, right? My z is negative 2. So it is kind of like about, I'm trying to figure out how to make this to where it makes sense. In the book, they made their z's a lot. Am I reading this wrong? X, Y, and Z. No, they did it right. I still don't know how they got there because it's a 3D. But my Z is 2. So when this brings down, this is where my second point is. We're not going to stress about it. You have some graphing to do. We're not really going to push on this, okay? The one thing that we do want to know how to do, and this is not going to be hard to do at all, is how to graph a linear equation in 3 variables. I'm trying to save my graph to the best of my abilities. I think I can do this. Here it goes. Okay. And we're trying to graph 3x plus 2y plus 4z equals 12. 4z equals 12. And we said in class the way we graph this is, we do the same thing we did with standard form, but now with 3 things. So first of all, we're going to say, well, what if x is 0 and y is 0? Well, then 4z equals 12. That means z equals 3. So I'm going to go on my z, and I'm going to go 1, 2, 3. Here's my z, 3, right? Now, I'm going to go, well, what if x is 0 and z is 0? So this is 0, this is 0. That means 2y, that's all that's left, equals 12. That means y equals 6, right? Well, where is y 6? 1, 2, 3, 4, 5, 6. The last one is, what if y is 0 and z is 0? Which means we just need to find x, right? We did z, we did y. That means we have 3x equals 12 or x equals 4. Please remember your positive numbers of x are on this side where your z and your y are negative, okay? Please remember that. So if we go 1, 2, 3, 4, that should have not been there, really. All I have to do now is unite the 3 and shade to say this is my equation, right? We shaded it. This is our equation. So in order to do this, you're going to have homework at home to do this. You make them 2 by 2 zeros, and you make sure you get a z, a y, and an x. You plot them on each specific axis. You unite them, shade it in. That is your solution. We are going to try now to do something that we've already kind of done in chapter 2, I believe, which is isolating one variable. So we have a linear equation. It's the same one. It has 3x plus 2y plus 4z equals 12. The first thing they're asking us to do, in example 3, we're on page 171, it says write this as a function of x and y, which means we want to end up with z equals something. Okay, z has to be alone. So first things first, I'm going to move my x and my y on the other side and end up with 4z equals, to move them on the other side, I have to make them opposites. Negative 3x minus 2y, and then I still have a 12 that follows through. Why did I do this, guys? Negative 3x, negative 2y, 2y, sorry, right? Negative 3x, negative 2y. This is gone, this is gone. I'm skipping steps now and then because I'm thinking we're past algebra 1. Here we are. The last thing we need to do is divide that 4 out, right? And because I don't want to write this really hardly, I'm just going to say I'm going to times it by its reciprocal. Times by its reciprocal, or divide the 4 out. It's the exact same thing. That goes away. Z equals 1 over 4, parentheses, negative 3x minus 2y plus 12, right? If I would like to open this, I can, and I will have a lot of fractions. I can rewrite this as f of x and y, and the reason I'm doing this is because I want to write this as a function of x, y. And I will ask you in your homework to do the same thing for me, okay? Rewrite this as a function of the two things you need to write out. The part B of this problem, it says evaluate this function if x is 1 and y is 3. Basically, it's like, what is z when x is 1 and y is 3? Well, this becomes f of 1, 3. That's what we're looking for, is 1 over 4. Negative 3 times 1 minus 2 times 3 plus 12. 1 over 4 times, let's do this mental math because we can. Negative 3 minus 6, negative 9 plus 12. 3 or 3 over 4. So my z is 3 over 4, right? Evaluate the function, interpret the result geometrically. Really, what this means is 1, 2, 3, z, y, x. X is 1. Remember, oh well, this should have gone through the middle of it. I'm sorry. X is 1. Y is 1, 2, 3. Z is just 3, 4, so it's about right there. There's my equation. Once we have the 3 values, we can graph the equation, right? The last thing left for us to do from this 3.5 is the word problem on the next page. We did this in class. We're going to do it now again. They're telling us about planting a lawn, and you decide to use a mixture of 2 types of grass. It's bluegrass and rye. The bluegrass costs $2 per pound, and the rye costs $1.50 per pound. To spread the seeds, you buy a spreader that costs $35. A, write a model for the total amount you will spend as a function of number of pounds of bluegrass and rye. First things first, the verbal model, right? The total cost, and I'm too lazy to write all the words, is going to be dollars for bluegrass times pounds. I'm just going to write LB of bluegrass plus dollars per whatever, like rye times pounds of rye. But you also have an extra cost, right? We have to rent or we buy a spreader. So it's dollars for spreader. This is what's going to cost you, right? How much money you pay for your bluegrass, how much money you pay for your rye. I don't even know what that is. And then you also have to buy the spreader to do it. So let's go ahead and replace what we know. The total cost, I don't know, I'm not, let me see, equals dollars per bluegrass, it's $2, times pounds of bluegrass, we don't know, 2x plus dollars per y, 1.50 times y, I don't know how much, right? But I do know I'm going to add a 35 because that's how much it costs to buy that spreader. And that's your part one, right? We wrote the verbal model. You have it in class. I didn't write it again. Then we replace what we know. We do not know what these are, so this is why these become our unknowns. We don't know how much pounds of each we buy. On the second, it says, evaluate the model for several different amounts of bluegrass and rye and organize the results in a table. Now, that's a lot of work, right? We really want to pick up different stuff and see the cost. And I'm just going to do 2 values. They did 4 values, and we're not going to stress about it. But here's what we know. This is rye, and this is bluegrass, okay? I'm only using 3 options. Well, what if I buy, let's say, 10 pounds of bluegrass and 10 pounds of rye? Well, you just plug it in here, right? This becomes 20 plus 15 plus 35. My cost would be what? 35, 70, right? Well, hold on. I didn't write this correctly. This is 10, 20, 30. I wrote this wrong. 10, 20, 30, and this is rye, and this is bluegrass. So if I buy 10 and 10, I pay $70. What if I buy 10 and 20? Well, it's going to be 20 plus 30, which gives me 50 plus 35 is 85. And then I'm going to do the last one, and then you can look in the book for the table. If I buy 10 pounds of bluegrass and 30 pounds of rye, then I get 20 plus 45, 65 plus 35, I get $100, right? For your homework, if you have something like this, I just need you to give me, again, 3 values and 3 values. Don't go overboard. You can even do, I would say 3 values and 3 values. And so forth. You take 20 and 10, 20 and 20, you plug it in. Your table is in the book. But if you're wondering how they got to this value, they went, this is for 10 and 10, right? If they went 20 and 20, this becomes 2 times 10 plus 1.5 times 20 plus 35. You put this in the calculator, you end up with 85. And then for 10 and 30, this is 2 times 10 plus 1.5 times 30 plus 35, which gives you 100. And that's how they went in and put it in. This is your X, basically, and this is your Y, basically. Okay? Now, I have assigned you homework. I haven't assigned you a lot, so I think you're gonna do great. So, happy homework.